All right, let's talk about a huge fundamental flaw that's sitting right at the heart of the entire AI industry. A flaw that's built on these massive, bloated, and frankly unreliable data sets. We're not just talking about some small improvement here. We are talking about a complete and total shift away from AI that just guesses and toward an AI that actually knows.
And this image, it just perfectly captures the whole conflict. On one side, you have what we call the imperial lie, this chaos of AI hallucinations, where the machine is just making its best guess based on a mess of data. And on the other, you have deterministic fact, a reality that's structured, that's verifiable. You see, the AI industry has pretty much accepted the lie because, well, it's easier and cheaper to just assume the world is neat and orderly than to actually deal with the fact that it's broken and chaotic.
You know, this isn't just a snappy line to get your attention. It's a real warning, because if the AI tools you're using are built on guesswork, you're not actually operating in reality. You're operating on a guess about reality. And honestly, that's a really dangerous place to be.
So what exactly is this imperial lie we keep talking about? Let's break down the fundamental problem that's baked into almost every single mainstream AI model you use today.
Think about it. Most AIs are trained on this gigantic, unverified data dump from all over the internet. They don't understand anything. They're just incredibly sophisticated calculators that figure out the statistical probability of which word should come next. And that is why they hallucinate. They literally make up plausible-sounding lies because their core architecture has no way to tell the difference between a fact and fiction. They are built to guess. They are not built to know.
Now, most of the industry is trying to fix this by detecting hallucinations after they've already happened. It's kind of like building a better smoke detector. Our whole philosophy is different, as it says right here. You're measuring the smoke while we've redesigned the engine to prevent the fire. We're all about preventing the problem at the most basic architectural level.
Okay, so if the old model is completely broken, what does the new one even look like? Well, this is it. This is the new paradigm. It's a fundamental move away from relying on flawed, dusty memory, and instead relying on real-time computation. And this is the core of that new engine, the MRAO tri-state grid. So instead of digging through a giant library of potentially wrong information, it computes truth right here, right now. Think of it as a system that doesn't recall old answers. It calculates a fresh, verified answer for every single query, and it only acts on proven, validated fact.
It all comes down to this really simple but incredibly profound principle. We don't guess, we verify. This completely flips the standard AI model on its head. The goal is no longer to sound plausible, the goal is to be provably true.
So how does this verification actually happen? What does an architecture that's built from the ground up for truth really look like? Let's get into the mechanics.
The first pillar is something called the Sovereign Truth Protocol. The easiest way to think about this is like a cryptographic fingerprint for every single piece of data. Every fact is tied directly to its source with a unique data citation hash. This creates a mathematical, totally unbreakable link to where it came from, making it literally impossible for the system to make a claim it can't back up.
And look, this isn't just some idea or a policy, it's hard-coded into the system. What you're looking at here is the actual Python code that runs the verification. That hashlib.sha256 function is a cryptographic workhorse. It mathematically proves that the data hasn't been touched. If even one single character changes, the hash fails. It's not a suggestion, it's math. It's basically physics.
Next, there's the corpus lock. This builds a completely impenetrable wall between the AI's public knowledge and your private data. And this is so crucial because it prevents data contamination, which is the main reason other AIs mix unverified internet junk with your sensitive information, which, you guessed it, leads to more fabrications.
But hey, a truthful architecture is only half the battle, right? It also needs an ethical operating system, a kind of constitution. And again, these are not just suggestions, they are hard-coded mandates.
This table here shows you exactly how those principles get translated into real actions the machine takes. Take 100% honesty. If the data is missing, the system's response is simple: unknown, no guessing allowed. Or integrity. It has a hard-coded defense that will just reject prompts that conflict with its core ethics. For truthfulness, every single conclusion comes with a digital evidence trail. And for self-verification, it's constantly running its own diagnostics, finding and fixing logic gaps all by itself.
And this might be the most profound rule of all. The AI is actually designed with what we call an active failure protocol. It is literally rewarded for admitting when it doesn't know something. In this system, saying "I don't know" isn't a failure. It's a successful, truthful response. It always prioritizes what's true over just the appearance of being helpful. So when you put all of this together, what you get is a glass box. You know how most AI is a black box? You throw a question in, an answer comes out, and you have absolutely no idea how it got there. Here, every single step of the process is made completely transparent. It's all auditable through forensic audit logs, which builds a level of trust that is just impossible to get with any other system.
Okay, but does this radical approach actually perform? I mean, it sounds great, but let's look at the data, because this is where the theory smashes into reality.
Let's start with efficiency. Simulating qubits is a great way to measure raw power. It's incredibly computationally expensive. Our unsubsidized cost per qubit is this ridiculously tiny number. I mean, that undercuts our competitors by a factor of 10,000. It just fundamentally changes the economics of high-level computation.
Now, let's talk about power. We simulated over 5,700 stable, near-perfect qubits on, and I'm quoting here, a cheap-ass x86-64 machine. This is the kind of raw power you need to compute truth in real time, and it proves that being the best isn't about having massive hardware. It's about having a better algorithm.
And this is how little hardware it needs to do it. These incredibly complex simulations, the kind that used to require entire data centers, can be run on just 4 gigabytes of RAM. This isn't just an efficiency gain. This is about democratizing access to computational power that was just unobtainable before. And finally, scalability. 1 million virtual qubits achieved on a standard off-the-shelf Ryzen baseline. This just goes to show that the architecture isn't some clever trick that only works on small problems. It's built to scale up and tackle the most complex challenges we can throw at it.
But why? Why build all of this? I mean, technology this powerful needs a mission. It needs to be grounded in our humanity.
And this is it. This is Bella's voice. It's an AI ecosystem designed to protect vulnerable children, especially those in the foster care system. It uses a simple smartwatch to analyze a child's biometrics, their heart rate, their breathing patterns, to create an objective, undeniable record of their emotional state. The goal, which was born from a real fight for justice, is to give the most voiceless members of our society a voice. This is that architecture of truth we talked about, deployed for a vital humanitarian purpose.
Which really leaves us with one final question. We're living in an age of rampant disinformation, where truth itself feels like it's under attack every single day. So, in a world like that, is an artificial intelligence that is architecturally capable of lying even an option we can afford?